A very good evening to everybody. Thanks for clicking on to today's video. It is Sunday the 24th of August and we are going to look at the early thoughts on the 25-26 winter for UK, Ireland, Europe and the Northern Hemisphere. This is not a forecast, nor is it even an update. That will probably come at the end of September, early October. But really, this is a mere appetizer of the building blocks to the forecast that will be released at the end of November. Be sure to hit that like button and subscribe if you're enjoying what you're seeing here on the channel. Tropical Outlook was yesterday. Tomorrow there will be discussion with regards to the scoring of the 2025 summer forecast. Really, it's been very successful over the last 3 consecutive years. In terms of winter time, I've been a little bit let down during the back half of the last 2 winters. The first half has played out not too bad. Nice correlation with the Enzo versus the movement of the Mad-Julian oscillation. That's been quite nicely correlated with positive and negative Arctic oscillations and North Atlantic oscillations. But generally speaking, the winter forecast, in the last couple of years at least, has proved less accurate the further out you go towards the back half of December, January. For example, we've had the much anticipated cold and at times snow. December and January actually. December was warmer than average last year. It was quite a cold January last winter. And then it turned out to be an exceptionally mild February, and that was not part of the forecast. So I will hold my hands up when I do get it wrong. Like I say, I just want to emphasize this point that this is all very early stuff, but it's just to give you a little taster of potential further down the road. So at this time of the year, I tend to look at what is going on within the Pacific, the SST profile within the Atlantic, with the type of behaviour of the summer just gone, what the atmosphere is really doing at the moment. And one aspect to consider is going to be what type of September we see here regarding the overall pattern. Very warm Septembers tend to lead to a warm winter. So we shall wait and see what happens here. This is not hype, this is not clickbait. This is purely showing you the evidence here. So let's get into it. At this time of release, the westerly winds are returning to the polar stratosphere, heralding the annual return of the polar vortex, albeit in its embryonic state. So what does that mean? Westerly winds return to the stratosphere over the pole. That marks the beginning of the development of the polar vortex, which starts, I believe, from top down. It's not overly evident when you look at the charts initially, but that will start to show. You'll start to see colder air beginning to gather over the top of the pole as we move into the first half of September. But as of now, Sunday the 24th of August, the westerly winds are due to begin around Tuesday the 26th, according to the ECMWF here. So the winds were going from easterly, negative, to positive, westerly. That marks the beginning. So what are the early factors? What do we know at this moment in time? So the question mark is going to be whether we get a warm or cold September for Western Europe. Possible return of La Nina. We don't actually have an actual La Nina at the moment, but it looks increasingly likely that we will see a La Nina redeveloping within the Pacific, whether it be Central Pacific or East Pacific. That is going to be something that needs to be monitored in terms of overall outcome to the atmosphere. We've got a negative QBO or quasi-biennial oscillation. What does that mean? I'll explain that in just a second. That has interesting implications potentially. We're going from a positive last year to a negative this year in the QBO. The Indian Ocean Dipole, the IOD, looks to be negative this year, and we're going to be looking closely at the Indo-Pacific SST profile. So in other words, the warmer versus colder waters within the tropics of the Indian Ocean and the Pacific is going to be potentially determines how strong and the position of the Mad-Julian oscillation during the winter season. Here's a little caveat for you here. This is a little out there thing to throw into the mix. Maybe not so much a caveat, but something to throw into the mix. There's been a spate of volcanic eruptions in Russia's far east in the last 12 months or so and beyond. But could that have an impact on what goes on over the high latitudes? That'll be a question. So if you're hoping for a colder winter, well, there's 3 potential positive factors to hold on to at the moment here. And these 3 positives are likely to continue through the autumn into the early portions of the winter. So La Nina, an easterly QBO, and a negative IOD equals the increased chance for high latitude blocking and a sudden stratospheric warming event in the following winter. So in short, the QBO, quasi-biennial oscillation, are a belt of winds which blow from west to east or east to west within the equatorial stratosphere. So that stratospheric level, so over the equator, the stratosphere is approximately 11-12 miles above the surface, above the troposphere where our weather exists. When you've got westerly winds, like we've seen in 2024-25, tends to be associated with a stronger polar jet, stream, and polar vortex. And easterly, which is expected during the upcoming winter, can, not always, but can have frictional effects on both the jet stream and the polar vortex, leading to a weakening and a buckling of the jet, which allows the polar air southwards towards the pole. La Nina, if, how strong, where? These are all the questions that we need to ask. While there's growing model support for the redevelopment of La Nina through the autumn, that's one thing, but how strong will it be and where? That is going to be important. Now, the Met Office model appears to be one of the most bullish of most of the major models out there, global models, for cooling within the equatorial Pacific, but particularly over the central Pacific, where those coldest waters are set up, is important regarding factors such as the latent heat release from the Madden-Julian oscillation. And that is something that I really love to look at. If you've been following me for some time, you'll know I mentioned the MJO both in the summer and winter, but the winter time probably even more so. But you can see here, this is off the Met model here. This is, in this little discussion, we're going to talk about the November, December, January period. So we can't look at the December, January, February period yet because the models are yet to update. That will come next month. So the first models for the December through February winter period will come next month, and we will discuss that later next month as well. But you can see here, according to the SST anomalies here, well, widespread warmth across the planet, but the standout is going to be those cold waters within the equatorial Pacific, more so towards Nina region 3-4, as opposed to 1.2, which is near the South American coast. What's important about this, very briefly, is the MJO, if you want to have high latitude blocking and, colder weather, you want to have that colder water a little bit further east and the warmer waters towards the central portion of the Pacific. What's important about that is when the MJO is in an active phase, so upward motion, thunderstorms, release of latent heat into the atmosphere, when it's over the west to particularly central portion of the Pacific, that tends to correlate to more blocking over the high latitudes and colder air within the mid-latitude pattern over North America, Western Europe, and Eastern Asia. So that is one aspect that needs to be addressed here, and we will only find that out later down the road. The position of that cold pool of the Pacific is going to be important. However, the combination of La Nina, East QBO, correlates to a weaker jet stream and more buckled and a weaker polar vortex, as well as greater chances of a sudden stratospheric warming. You can see this little graphic showing a strong polar vortex means stronger polar jet and much more oceanic influence on the North American and Eurasian land area here. The cold is bottled up to the north, tend to have more mild westerly winds pulling Pacific air over North America, Atlantic air over Europe here. When you've got a more amplified, buckled, weaker jet, a more wavy jet, meridional, you've got colder air released into the subtropics, or at least into the mid-latitude, should I say, and warmer air can move northwards here. So we've got warmer air moving north, we've got colder air moving south when you've got this more amplified, more wriggly, buckled jet stream. That is what the polar vortex is in its strong versus disrupted or weak state. Now, another positive factor, if you wish for a colder or early onset to winter, is the negative or negative IOD, Indian Ocean Dipole, which looks to be going into negative territory, as this graphic suggests, which is somewhat interesting here. The combination of La Nina, East QBO, negative IOD all tend to lead towards, like I've already said, and this maybe a little bit repetitive. In fact, I might actually adjust that one, but it leads to the increased chance of a negative Arctic oscillation, North Atlantic oscillation. So a negative Arctic oscillation is when you've got this more weaker polar vortex. You've got higher pressure within the Arctic region. You've got lower pressure. Colder air gets released into the middle latitudes. The negative versus positive Arctic North Atlantic oscillation, and positive North Atlantic oscillation, you've got generally westerly winds and mild conditions specific in the North America, Atlantic into Western Europe. The negative North Atlantic oscillation is when you've got this. So the positive NAO is when you've got a strong low pressure over Iceland, strong high pressure over the Azores, and you've got the jet in between the trough to the north and the ridge to the south. Tend to have cooler, drier conditions across the Mediterranean basin. You've got warmer conditions across Northern Europe, including the UK and Ireland here, mild. When you've got a negative North Atlantic oscillation, you have a weaker Icelandic low, you've got a weaker Azores high, you've got much more blocking up towards Greenland here, you've got the jet pushed further south with troughs either side of that over North America and over Western Europe, allowing the release of Arctic air into Europe here. Cold, dry Scandinavia, including the UK as well, potentially. Warmer, wetter across the Mediterranean basin here. So basically, La Nina, easterly QBO, negative IOD, favours the weaker polar vortex, so a more greater chance of seeing a negative Arctic oscillation and North Atlantic oscillation. Another interesting one, so like I said, about the recent activity within Russia's Far East. So recent volcanic eruptions in the Kamchatka Peninsula that is basically up against the Pacific Ocean. So what's important to remember, the depth of atmosphere is greatest at the equator, least at the pole. It's when ash and materials get released from eruptions, ejected through the troposphere into the stratosphere. That is important. So volcanic eruptions are one thing, but when they're strong enough and they release the materials, particularly sulfur, for example, into the stratosphere, so it penetrates through the tropopause, which separates the troposphere from the stratosphere. When it penetrates into the stratosphere, that's where it can have lasting effects within the atmosphere. Primarily, high latitude blocking can occur. And the last case of a high latitude eruption, so this is another important factor. It's all very well saying volcanic eruptions. We get that in Indonesia all the time. We get them in Russia all the time as well. But the depth at which this release from troposphere into the stratosphere is important here. So basically the atmosphere is a much more shallow. The depth of the atmosphere is much more shallow towards the pole as opposed to towards the equator. So it takes less to release materials into the stratosphere. The further north you go, it takes a lot more energy, much more, much more of an ejection of atmosphere into the atmosphere from the tropics to release that energy all the way up into the stratosphere. The last case of high latitude eruptions enhancing a negative Arctic Oscillation, North Atlantic Oscillation is probably 2010 in Iceland. There have been multiple large-scale eruptions in Russia's Kamchatka Peninsula over the last 12 months or so. August last year saw the Shivluk blow, releasing ash into the stratosphere, followed by the first ever recorded eruption of another volcano that I'm not going to try and pronounce. That was back in May. So, like I said, the height of the stratosphere varies from 11.12 over the tropics to only 3.4 above the pole. The Shivluk volcano in the northernmost part of Russia's Far East Peninsula is at a latitude of roughly 56.6 north. That's pretty much the same as Scotland. And so the stratosphere is roughly 6 to 7 miles above the surface at that latitude. How much effect these recent eruptions may or may not have is unknown to the stratosphere, but they generally, if you can eject this sulfur and other materials into the stratosphere, especially over higher latitudes, you've got an increased chance of seeing blocking and the development of a negative Arctic Oscillation, North Atlantic Oscillation. So we'll wait and see what happens. That's one aspect, a little side element to consider. Some negatives. Over the last couple of decades, hot summers have traditionally, so we're coming off the back of a hot summer, traditionally have not been followed by a cold winter. So that's good news if you don't want a cold winter. It's bad news if you do want a cold winter. So that's one aspect to consider. The last time we seen a hot summer followed by a cold winter was 30 years ago, back in 95, 96. So that being said, the parameters are very different now compared to then, with all the background warming. So obviously we've got a much warmer ocean atmosphere, land area in 2025-26 as opposed to 95-96. I've said for several years now that these analogues that we love to look at, the teleconnections that we really go by, aren't as effective, I don't think, as they once were, due to the lack of difference in sea surface temperature anomalies locally as well as globally. Additional thoughts for those winter lovers? Let's hope we don't have another warm to hot September. They're more often than not followed by warm winters. As for the tropics, well, the Pacific and the Atlantic activity, especially recurving tropical cyclones, are well known for driving heat north, not only into the mid, but also the high latitudes of the northern hemisphere. So this release from tropical systems up into the northern hemisphere can force negative Arctic oscillations, North Atlantic oscillations, and intrusions of cold south during September, October, and even November. So the effects of the tropics at this time of the year become more important, and busy ends to Atlantic hurricane seasons have been linked to cold Decembers in the past. A couple of years ago, I think we did see that cold December, and that was possibly due to a lot of late season tropical activity, energy, warmth, humidity getting released all the way up into the Arctic, and then forces high pressure to develop. So, if you want me to put myself in the line as of late August, I would lean towards a cold December, possibly January, followed by a milder end of January and February. So a front-loaded winter is what I would think if I was to hazard a guess, and it is purely a guess at this early stage, but the possibility of a front-loaded winter, especially when you've got La Nina in place, you tend to have cold first half of the winter, milder second half. I want to show you this here. This is the November through January of the Met Office model here. This is mean sea level pressure, and you can see here that we've got generally low heights over Greenland and Iceland, positive heights to the south. That looks like a very mild November, December, January period. This is obviously over a 3-month period averaged. Obviously, it's still a long way off for one, but for two, this is a very long period of forecast as well. So there would be fluctuations in between this, but generally speaking, especially when you've got a lot of low pressure over Australia, over Indonesia, over the West Pacific, that tends to support more of a phase 5, 6, or phase 4, 5, in fact, of the Mann-Julian oscillation, which would correlate potentially to a negative over Greenland, positive over Europe, and that would be a positive AO NAO, which would be mild for our part of the world. That's the Met Office model for the November, December, January period. This is what the ECMWF is suggesting. It is literally the opposite. So these models, take it with a major grain of salt. It's just models. They're going to chop and change. They're quite often wrong. But this ECMWF is almost polar opposite to what the Met Office is showing for the same time frame. Showing blocking up towards Greenland and Iceland more of a negative, just to the south of the UK and Ireland. That looks like quite a cold signal. Bear in mind, if this was to play off, that would be interesting given that it's a November, December, January period it's talking about. So this article is going to get released early on Saturday morning, so you can check that out. But hope you've enjoyed these early thoughts. Like I say, it's not a forecast, it's not even an update. It's just purely to whet the appetite moving forward here. Enjoy the rest of your Sunday, and all being well, I'll be back tomorrow with the scoring of the summer 2025. Bye for now.